Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 6 of the April Daily LeetCode Challenge. I am assuming that you would have given today's contest also. Today it was a Sunday basically, and we had a weekly contest today. So I'm assuming you would have already given that contest. That was on a very good level. And today's question is also on a medium question. And it is among the first 500 questions that we have on LeetCode. Okay, and it is on a medium side. And yep, if you see, the length is going to be up to 100, so this is not on a very hard side, this is on a easy side. Even slightly, if you understand, like, see, it's not about the brute force or the optimized approach. It's about, if you understand the question, if you know how to implement it in a slightly better way, then definitely you can try this question, it will work. Okay, you don't have to think about the brute force, but definitely you have to advance certain tricks, and if you can do that, you can solve it. Okay, you can go up to a offense solution. That will be the hint for you. So now, coming to this question, what we have to do is see it is largest divisible subset. So what we are given is, basically, we are given a set of nums. Okay, if you see the properties of that, all the numbers are going to be positive and they are going to be up to 10 power 9. Okay, and also one more thing is, they are all going to be unique. That is another important point. Next, they are saying that given a set of distinct positive integer nums, return the largest subset. Okay, they are asking for the largest subset, such that every pair, okay, they're talking about every pair in this particular set of elements of this subset satisfies this particular property. Okay, remember that is a or mentioned. See, this is or condition, it is not a and condition. Many people do not understand this part. Okay, they get confused and they do not understand what is happening. So it is very important to see that it is a or condition. That means either this is true or this is true. Okay, that is what they're trying to say. Okay, if there are multiple solutions, return any of them, but ideally what you have to do is, you have to find the largest possible subset and you have to return the set. Okay, you can return the set in any order, by the way. It need not be like in a sorted way or anything like that. Okay, so let us take the example. Let us go for this particular example. Okay? Example number 2. Okay, in this, if you see 8, now see, this condition, if you try to understand what is happening, they are trying to say that every pair, okay, in this particular set should have this particular property. That is, every number should be able to divide the other number. Okay, either way around. Okay, that is, you can think of like the smaller number should be able to divide the bigger number completely. Okay, now, if you see this first 8 is there, okay, 8 is the starting element. Remember, we'll go from, see, ID is very simple. We'll sort the set, we'll sort the given nums, and we'll start from the largest element and go to the smallest element. Okay, we'll go from right toward the left. So let us come to 4. Okay, 4 can divide 8 completely. Okay, now I'm at 2. Okay, now we'll see whether 2 can divide 4 or not. Okay, remember, if 4 can divide 8, and if 2 can divide 4, that obviously means 2 can even divide 8. Okay, please answer this property. 4 can divide 8. Okay, that is fine. But when we are at 2, we will see that whether 2 can divide 4 or not. If 2 can divide the smallest element in this set, okay, currently the set is 4 and 8. Okay, currently the set is 4 and 8. If the next element to be inserted, that is 2, can divide the smallest element in the set, that is 4. Okay, that means 2 can divide every other element that is there in the set. Okay, so if 2 can divide 4, it can also divide 8. Okay, so now 2, 4 and 8 becomes our set. Then we'll go for 1. Okay, similarly 1, if 1 can divide 2, that if that is 2, then even it can divide any other element in the set. Okay, that means every possible pair now, it will satisfy this particular property. Okay, the smallest element will completely divide the largest element. Okay, simple as that. And same is the case. Okay, in this case, all of them are part of the set. Okay, now if you go for example number 2, in this case, if you see, first set is 3. Okay, now we'll see whether 2 can divide 3 or not. Now, so in this case, 2 cannot divide 3, so we cannot do anything. Okay, 2 will be individual set, 3 will be individual set. Okay, now coming to 1, 1 can divide 2. Similarly, 1 can divide 3 also. Okay, 1 can divide 2, 1 can divide 3 as well. Okay, now if you see this case, two sets are getting formed. Okay, 1 can form a set with 2 also. Similarly, 1 can form a set with 3 also. Now since the loop is getting ended, whichever is the maximum set will return. In this case, both the sets formed are of same length, 1 and 2 and 1 and 3. So you can return any one of them. Okay, so in this case, they're returning 1 and 2, and they're also mentioning that 1 and 3 could be the answer. Okay, so there are going to up to 1000 elements. You can go for O and square approach. That is going to be the end for you. Now let me show you what I have done. Okay, so yeah, I will just show you the output first, then we'll go for it. Okay, first thing that I've done is I've sorted the nums. Okay, then we'll go from last index to the 0th index. Okay, so see, as you can see, this is what we have. Okay, so what I've done is, for each one of them, okay, after sorting, okay, basically what I've done is, see, these are the sorted list. Now what I've done is I've created a separate DP array. In the DP array, initially each element will have a set of its own element. Okay, that is like this will be set of 2, this will be set of 4, and this will be set of 8. Okay, something like this. Then we'll start the processing. Okay, so at index number 2, we'll start the processing. Okay, now what we'll do is, we'll see whether 4 can divide 8 or not. If that is the case, what we will do, we'll merge the elements that are there in the set of this with the element with the set of this. Okay, so 8 in this case is getting merged with 4, and it is forming 8 and 4. Okay, currently we are at index number 2. Then we'll go to index number 1. What will happen, same thing we'll do, we will see whether 2 can divide 4 or not. If that is the case, all the elements that are in the set of 4 will be merged with the elements of the set 2. Okay, so in this case, these two elements are now merged with this particular element. So in this, if you see, we are having this element now. Okay, 8, 4 and 2. Okay, now same thing here, 1 we will now see if 1 can divide 2 or not. If that is the case, yes, we will merge this set with this set now. Okay, so now we'll get 8, 1, 2, and 4 here. Okay, and the rest of the things will remain the same. At last, we'll go through this array again and see which is having the set with the largest number of elements. That will be our answer, and that's where we're going to return ultimately. Okay, if you go for example number 1, similar thing is happening here. If you see what is happening, we'll start with the next number 1. In the next number 1, we are not doing any processing because 3 cannot be divided by 2. Okay, then finally we are coming to 1, and here in this case 1 is dividing 2. Okay, something like that. That we're ending that. Okay, now let us see how I'm coding it. First of all, I'm capturing the length, and then I'm sorting the set. Then I'm creating a DP array. Okay, in this DP array, basically there are going to be n elements, right? There are going to be n elements, and each element is basically a set. Okay, each element is a set. So this is basically a list of sets. Initially, all the sets will have that particular element only as their first element. Okay, for example, if you see this element will have a set of containing 1. Similarly, the second element will have a set containing 2. Third element will have a set containing 4, and so on. Okay, they will contain their own elements first. Okay, then I'm printing the sorted set first of all. Okay, and then I'm using two for loops. Okay, they're using two for loops. What is this? Let me go through it. Okay, so the first for loop will learn from n minus 2 index and go till the last index. Okay, n minus 2 till 0. Okay, then in this particular for loop we are having two variables. First will call the max, second is called the max index. Okay, max is 0 initially, max index is c. Max basically means that which set, okay, in the towards the right. Okay, I'm at index I for all the indices which are towards the right of I, that is I plus 1 till n minus 1. Okay, I'm going to say which is having the largest set. Okay, I will record the length of that here. Okay, and once I find the set with the largest length, the index of that will be recorded here. Okay, as simple as that. So what I'm doing is I'm going from I plus 1 till last index. Okay, I'm just checking if nums of I can completely divide nums of I. Okay, nums of j, sorry, nums of I can completely divide nums of j. If that is the case, that we have a possible answer, but we have to see whether it is the largest one or not. Okay, so I'm taking the length of dp of j. Okay, currently dp of j is my something that I'm going to consider if to be merged with dp of I. Okay, so dp of j I'm taking the length, it's called double n. Okay, if double n is greater than max, what I'm doing is I'm recording it max equal to double n. Remember, max is basically the max length. Okay, I should have written max length here like I've written max index, but I did not write the length here. So let me make a entry here. It is going to the max length. Okay, as simple as that. So max equal to double n now, and max index equal to j. Okay, this loop will keep continuing, and once this loop completes, okay, what we'll do is we'll see if max index is not equal to minus 1. That is, see, minus 1 is the starting value, right? If it is anything other than the starting value, then what we'll do is that means we have now a particular set which can be merged. Okay, as simple as that. So this will do a set union. So whatever elements were there in the dp of max index, that will merge with dp of I. Okay, this is, I'm using a shorthand basically. Okay, the dp of I is equal to dp of I union with dp of max index. Okay, so this is basically set union. This is a set operation in Python. You can directly do using this particular operator. You can do the set union. You can also write in a word. Okay, and dot union, like that you can write it too. But again, there is a operator for this purpose. I'm using the operator directly. Okay, and at last, since there is operation done here, what I will do is I will just write the index equal to, and I will write the index here, and then I will write the DPR. Okay, that I've shown you previously, right? Now, once this is done, okay, let me once again show you the output. See, once this is done, like see for index 2, it will print this. Okay, that is after processing index number 2, what is the set of the DP? Similarly, after processing index number 1, what is the set of the DP? What state of the DP? And similarly, while processing index number 0, what is the state of the DP? Okay, I'm printing everything just for convenience. When you're segmenting the solution, comment out all the print statements. Okay, then what I'm doing is, see, among all these things, basically, I now need to know the largest set possible. Okay, that will be our answer, right? So what I'm doing is I'm creating again two variables. First is called the answer, second is called the max length. Okay, answer is basically again it's going to record the index. Okay, so what I will do is I will go ahead and write the word index here. Okay, it will record the index of the DP which is having the largest set. Okay, as simple as that. And similarly, this is for the max length, right? Now what I'm doing is I'm going through each element from 0 to n minus 1. Then I'm checking what is the length of the DP of I. Okay, it's, remember, DP of I is a set. For the set, I'm recording the length. Okay, if the length is greater than the max length, then I'm just updating these two variables. I'm recording its max length, and at the same time recording the index for this, because remember, this is the set that we have written at last. If this remains the bigger one, okay, last. So once this whole for loop completes, finally for DP of answer, we are returning it and converting to a list. Okay. See, what I did is initially I did not convert to a list. I just returned DP of answer. It was throwing error that, okay, you are not sending in the right data type that was mentioned in the question. Okay. So since the return type is list, so finally I'm converting to a list and I'm sending it. Okay. So yep, this was the question. I've already segmented the solution and it got accepted. So my request to you, go through the question. It's definitely easy one. Okay, there are a lot more things to happen, but yeah, this is the easy level question. In a contest, you can expect this to come in as a question number 2. Okay, in LeetCode contest, we are usually 4 questions. This can be your question number 2 in that. Okay, and yep, go through it and see this. What you have done is this is the DP approach that I will say. Okay, just remember one thing. Ideally, what you have to do, no, when you are forming a set, basically you have to ensure that every pair is satisfying this property. Basically, okay, every pair is satisfying this property. But in my case, if you see, I'm doing only one division to basically check whether a new element can be added to a set or not. Okay, so the idea here is I am using the, see, I'm not repeatedly solving the sub problems. Okay, since the sub problems are overlapping, what I'm doing is I'm solving them only once and using those results for the other cases. For example, if you see, let us say 4 and I will again explain this. See, for example, 4 and 8 are there, right? 4 completely divides 8. Okay, now if 2 can divide 4, okay, if 2 can divide 4, I can conclude that even 2 will divide 8. Similarly, if there are any more elements bigger than that, then 2 will divide that also. Okay, so that is the idea I'm using. If 2 can divide the smallest element in the set, that means 2 can divide any other element in the set. Okay, existing element in the set. So that logic I'm using, and I'm you're building that set. Okay, remember, this is not a brute force. It's a very wrong way to say this is a brute force, because I mentioned this, the logic that I mentioned, if you're using that, that cannot be called a brute force. Okay, in the brute force, actually it will mean you're going through each element in the set and checking for each pair whether each one is the smallest one in the pair is dividing the other one or not. Okay, so definitely it is not a brute force solution. This is kind of optimal solution that we can have. Okay, so Yapan, that was all for this particular video. I've tried my best to show you whatever is possible here, and please let me know if you have any doubts. And if you like my content, if you like the quality of the content, please subscribe to our channel. This really gives a lot of motivation to continue further. This was my 166th day, and there are many more days to come. See you tomorrow. Thanks a lot.